In today's episode,
Of course, wireless they always get all the glory.
And all the blame.
troubles at Cisco Live, just before showtime.
You see it crash on one, time later it would crash on the other.
Brandon is in rush to find a solution for these mysterious crashes.
That would be snooping the packet and crashing.
Have you guys tried to send that malicious packet again?
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Hey everyone, and welcome to Cisco Tech Stories. Can you believe it? This is episode 24 and the very first episode of our third season. Time really flies. We kicked off this podcast 2 years ago, and here we are starting another exciting chapter.
Yeah, it's been such a fun journey so far. We are so glad that you guys stick with us. I'm Tristan, and of course, I'm joined by my co-host, Nico. Hey, Nico.
Hey Tristan, and hi to all of our listeners. It's great to be back. We've got a really exciting episode to kick off this season. Cisco Live San Diego just wrapped up a few weeks ago, and there was no shortage of big announcements and groundbreaking innovations.
Yes, absolutely. As much as Cisco Live is about showcasing cutting-edge technology and products, there is an incredible even team working behind the scenes to make sure that everything runs smoothly, from world-class sessions to network that powers it all.
And today, we're thrilled to have a very special guest joining us, Brendan Wall, a technical leader in the CX Enterprise Group. Brendan has some amazing stories to share about running the NOC at Cisco Live 2024, so last year, and trust me, there's a lot more to it than you'd expect.
Yes, we are diving into the behind-the-scenes magic that makes Cisco Live happen. So whether you're such a tech enthusiast, an event planner, or just love a good story, stay tuned. This is going to be a fun story. Shall we get started?
And today we have Brendan. Hello, Brendan.
Hello, Brandon.
Hey Nico, how are you?
Pretty good. So I heard you just back from Cisco Live, right? We're going to talk about that. So can you introduce yourself a little bit first?
Sure. Yeah, my name is Brandon. I'm a technical leader for the Catalyst switching product line in Cisco Tech. I've been at Cisco for about 9 years now, and six of those has been in the enterprise switching TAC team. I've been a technical leader for about a year now. So working escalations, I tend to focus a lot in like automation, innovation, in the enterprise side of the house, specifically, tooling to help our switching engineers either solve cases faster or analyze data. So that's kind of my hobby, not hobby, but it's what I like to focus on outside of just typical casework is the automation aspect of it.
And where are you based?
I am in RTP, North Carolina, so East Coast, United States.
Very big center. I've been there once, like lots of buildings.
Yeah, there's like 12 of them, I think, and we only have a couple populated now, but still a good campus.
Okay, so what story do you have for us? You're part of the NOC, and I think your story is Cisco Live NOC related, right?
Yeah, so Cisco Live Not 2024 was the story. Specifically, an issue we ran into the day before the show that was, potentially going to be catastrophic to the success of the entire show.
Okay, can you take us back, like, the chronological order when you arrive there? What happens to, what do you set up, etc. I think last year was in Las Vegas, right? So how did it look like until that, day before where it's panic?
Gotcha. So part of it is, there's an event, like just a little bit of background, if that's all right. There's an events team that focuses on, like, their job day to day is setting up or getting ready for the shows. So they do like Cisco Live in America. Then after that, they do Cisco Live APJC. Some of them do the EMEA show. So they're always getting ready for the next show. And part of that is getting to the venue about 5 days ahead of time for the early install because it's just an empty warehouse 5 days before the show, and then they get there, they're rolling out the 500 access switches, the core gets powered on. When the show starts, the uptime of everything is less than a week, so there really isn't a whole lot of time. And so we get there, I think, on Tuesday, and you basically just get your laptop set up. You don't really accomplish too much Tuesday, so that gives us Wednesday, Thursday, Friday, Saturday to get everything set up. Our monitoring is in place and the network is stable, right? And we know, being that I support the enterprise network on Cisco Live, so like, the routing and switching, having that set up is important for everyone else that uses the network, right? So wireless, of course, they always get all the glory on the Cisco Live network because,
And all the
you
blame,
know,
and all the blame.
yeah, that is true. Well, I don't know. Typically it comes to the network team, the enterprise side first with network issues, but it does turn out to be a lot of wireless problems there. We want to make sure they're up and running. They have a ton of controllers. It's kind of funny to me actually. They have like 8 wireless controllers. One for the
You never have
keynote.
enough.
Exactly. I was like, you're going to have more controllers and access points at some point. And they do a good job, but yeah, getting there ahead of time, making sure all of our monitoring's up. And then for the wireless specifically, that's always like the most important node for us on the wired side because we do centralized wireless. All the wireless clients are coming out from all the APs on this device, so we need like a big beefy device that can handle all of the ARP entries and all of the IPv6 neighbor entries because we do run dual stack. We need a lot of TCAM space for ARP.
It's one big point of presence, right?
Exactly. It's one big /16 SVI. All the wireless is coming out there.
And what are the numbers, like top maximum amount of clients and like ARP entries? What did you max out?
I think that year we probably topped out around 22,000 ARP entries. And then a little bit more than double that for IPv6 because we have a link, clients have a link local and a global IPv6 address.
So when you say 22,000, you mean simultaneously or in total for the entire conference?
Simultaneously. So when we have the monitoring, we use, last year we used Grafana. This year we used Splunk since we paid a lot of money for it. But yeah, the high water mark was probably around 22,000. And then it was a little bit more this year, actually. In San Diego, I think we hit 25,000 at some point. The fact of the matter is we need a big stable device with a lot of TCAM that can maintain those ARP entries. And historically that's been a Nexus 7K switch. Well, 2 Nexus 7K switches. They're in like a virtual port channel, if you're familiar with that. So it's 2 physical devices, but one logical device to the rest of the network. And I guess getting in sort of the problem is the day before the show, we noticed that the DHCP snooping process was crashing. We saw it in a syslog, right? Like there's 3 of us there. My colleagues, Chris Gabrielson, principal engineer, and Richard Furr, also principal engineer. We have like a big TV kind of near our workstations in the NOC, and we saw that the Wi-Fi distribution had created a DHCP snooping core file. Like, well, that's weird, like DHCP snooping process crashed.
Why do you need DHCP snooping in the first place?
Well, that's the thing. We don't run DHCP snooping. So we didn't quite know why the DHCP snooping process itself was generating a core. So we see that crash, and it's like, well, that's strange, but it was just once. So we kind of chalked it up to, well, we'll keep an eye on this. But that's a little bit odd and concerning. As we got closer to showtime, that means more traffic is coming onto the network. We saw it happen with more frequency. I come from a Catalyst background, unfortunately at the showtime, like I'm not a Nexus expert, but basically the way it works is we have 2 devices, right? And if the process crashes on one, we still have the other switch that's able to handle that. But we were seeing that the process was starting to crash on both of those. So like we have Nexus 1 and Nexus 2 in the VPC. We see it crash on one, then another, sometime later it would crash on the other, never at the same time. Because if they crash at the same time, then we
This
have a
means you
problem.
lose redundancy if they both crash at the same time, right?
Exactly. Yeah. And if there's no redundancy, there's no wireless. Right. And if there's no wireless, then
There's no network.
for the
People
sake of
notice.
Cisco Live, yeah, there's no network for the attendees pretty much because it's in this big, metal convention center. There's no great cell signal or anything like that. At that point, we pulled the core file off, and the core is just a memory dump of what happened, and was able to see a trace back on the modules because the Nexus architecture, it's distributed, so like the module would have the core file. We pulled that off and was able to upload it to our like we had created a test case internally, to have TAC looking at it as well. And I was like, well, I want to decode these traces and see exactly where we crashed. Maybe that would give us some clue as to what's going on because like we know that it was DHCP snooping, but like that's an access layer feature. We're not running DHCP snooping on the wireless distribution. It's just that was a bit strange, but it kind of gave a clue as to it being DHCP related because that thing was DHCP relay for all the wireless clients.
And that crash was crashing the whole Nexus, right? The whole box, not just the service.
The process would restart, but so I'll get to there's more to it than that, right? Like so So basically, like, if the process crashes like more than 4 or 5 times in quick succession, the entire module will reload, right? So we weren't seeing the module reloading initially. We were just seeing the process crash. But as more traffic was getting on the network, we started to see the module reload. And that's where it starts to worry us because if the module reloads and we have the other module, and if that module reloads, then the network is gone. Like the wireless is totally
Mhm.
done, totally down. And it can't really get much worse than that from a wireless perspective, because the control, all the APs will reboot and they have to rejoin. And it's probably like 10, 15 minutes for all of that to come back. And if it's happening over and over again, then that's just, basically a nightmare scenario. So once we were able to identify, or I was kind of able to identify that through the traceback, I just pulled up the source code. It's like, okay, I've got this function here. I can see where it's crashing. I'm going to pull up the source code. And I was able to determine, and I'm no like C programmer, but some of the stuff you can with having any programming background, you can kind of make sense of what they're trying to do, and with function names, like what it's responsible for doing. And we were able to see that it was crashing in an IPv6 DHCP v6 function. So that kind of helped us narrow down, like, okay, it's something IPv6 DHCP related. It doesn't really help like determine what specifically about that was crashing, right?
And you're not using DHCP 6, right? I guess you would use Slack.
So we do Slack, but we also have some options for DHCP
Okay.
v6, right? So the DNS is all they use DNS that comes from IPv6. So we have like the managed config flag set on the SVI configs. The function specifically I was able to start looking at was like, well, it's parsing the DHCP v6 options, and from there it's just crashing somehow. So talking with Richard and Chris, it's like, well, we're looking for kind of a needle in a haystack, right? Well, not quite a needle. Like we have an idea what the needle looks like, but we don't know what needle it is, right? Because like there's a ton of DHCP v6 traffic on the network.
Yeah, you don't just take a packet capture and randomly, look at which packet could cause this.
Right.
Like there's just too many.
But at least you already know it's a DHCP 6 packet, so it reduced the amount of packets you need to look into, right?
Right. So that was really our only option. Like it's getting late. We have a problem. We have to do something, like we have a core file. We know it's within some DHCP v6, but like there isn't really a workaround, like we can't turn off DHCP6, DHCP or IPv6. I mean, we could, but we don't want to do that, like we need DHCP or IPv6 on the network. Cisco Live, can't not have a dual stack network. So really our only option was like we have to do PCAPs and just start looking at the packets, right? So on the Nexus, you can do an in-band capture. Basically, it allows you to packet capture the control plane, right? So anything going to the CPU of the switch. So it's like, all right, let's get this, let's run it. So we would turn on the PCAP, run it for a while, stop it, start it again. We were trying to capture the CPU while the issue happened, right? Like when we saw a DHCP snooping core file. It took a while for that to happen, but we finally got a packet capture of the CPU when the issue occurred. So like, all right, let's
So
pull
if
the
I understand correctly, DHCP snooping is the whole feature is about sending DHCP packets to the CPU for inspection, and then you can inspect for security. Like, is it a rogue DHCP server? Do we have duplicates? Blah blah blah, etc. Right. So that's why you're
Correct.
talking about taking a packet capture on the CPU because it's not a traffic that is just forwarded and sent to the CPU.
Right.
Okay.
And like considering we're DHCP relay, like we're gonna have to like the control plane is in charge of, kind of taking those server messages, sending them back to the client, and vice versa. So it was our first starting point was like, let's see what the DHCP snooping process is doing. And like it's different from Catalyst. DHCP snooping is like an actual like we snoop the server packets before we send them to the client, so we can keep track of that. Obviously, architecturally different on the Nexus, but it's still in charge of looking at the DHCP packets nonetheless. So that's why we get the capture, we pull it off, and we start looking at them, right? Like, what's weird about this packet? Okay, that packet looks fine. Let's keep going down. And I don't know if it was luck or what, but we stumbled upon a DHCP v6 packet that didn't. I don't know if I can't remember, if I don't want to say specifically what, but we found a packet that looked weird in regard to DHCP v6 option. Like there's certain options you'd expect to be there, and this packet didn't have it. So it's like, this is a suspicious packet, but we still have no way of knowing if this is our packet of interest. It's just a packet at that point. So what do we do?
I'm still confused because you said you didn't have snooping enabled, but you still see packets being sent to the CPU. So why was the Nexus even looking at the packets if
Because since we're doing the DHCP relay, like we're sending, so the packet comes into the Nexus, we create a new unicast packet to the DHCP server, and then that server sends it back to us, and then we send it to the client.
okay. So that's what the CPU was doing. Okay.
Correct. Yeah, it was doing DHCP relay. In fact, I think it would make more sense if the process was called like DHCP relay. I don't know why they call it snooping. It would make more sense anyways. But it was
It
doing
just
DHCP relay.
it just does all the DHCP tasks, I guess. It's just the DHCP
Exactly, yeah.
process in charge of inspecting and then doing stuff.
Right. It's parsing everything in those DHCP packets and figuring out, what it should do with
Okay.
it. But yeah, we found the suspect packet and was like, oh, this is interesting. And one of our colleague Chris Gabrielson, and we're able to take that packet, and he took the packet and he put it into I don't know if you're familiar with like Colasoft Packet Player, but it's basically a program you can use to replay a packet and send it out
Yep.
into the network. He no, he was doing it at the time, but he replayed it in Colasoft, and I guess he replayed it too quickly because he sent like some, I'm having a little bit of time remembering. I think it was some level of packets per second. I don't know if it was 100 packets per second or 10 packets per second. But the next thing I know, the wireless guys, because in the knock, like we have like a seating chart. We sit at one end and the wireless guys sit at another. Next thing I know, the wireless guys stand up and they start looking around and they look over at us and they're like,
Who did something?
"Did you guys just make a change?" Yeah. Did you guys make a change? And Chris looks up, he's like, I just replayed this packet. Well, both of the modules crashed on the Nexus at the same time when he replayed that packet. Like I said earlier, one packet might crash the process, but with Nexus, if the process is repeatedly crashing, it causes the modules to reset. And that happened for both Nexus at the same time. Like we crashed one module, then the packets were hashing over the link to the other Nexus. We crashed that module, wireless totally down. And that's where we were at that point.
Now I have a big question. When was that? Was it like after hours or was it
It was approaching that
during
time, so
the
like there was no traffic on the network, or sorry, there were no like customer attendees on the network, right? Like the network is still live.
Yeah, it was before the event.
Right. It's the day before the event. And it
Okay.
was approaching that like late afternoon, that time when you like kind of want another like, coffee or something like that, but like, getting close to the end of the day.
So impact was kind of less, right? Because even the workers, people setting up the event, they were not all there. Like kind of went unnoticed maybe.
Less, yeah, less, but also like thinking forward, because that's the thing. Is like, okay, like, well, now we know what the problem is.
That's the good news.
It starts to get stressful because it's like, what do we do about it? There's no way, there's no workaround on the like, because even being from a background, you have that. Okay, we have this catastrophic problem. What can we do to work around it on the device? And the answer there is nothing. Like,
But wait a second. You do have a PCAP, right? So you can just look into the PCAP for the source MAC address and go hunt for that host and take it offline, right?
right, and that's we saw it from a few. Right. So it was not just one, it was a couple of hosts. And thinking back now, it's like, well, it could be like some specific vendor's implementation, DHCP v6 causing it. But it wasn't just one host, right? Because, yeah, if it was just one host spamming, sure, we block that guy from the network, right? We block his Mac or something. But the fact that we saw it from more, and like we couldn't really, during the show, if we were just waiting until it crashed, get a PCAP, block that guy, like we couldn't, proceed like that. But I get your point. Yeah. Could we just block the host? But then but at the same time, we know that there is a way to crash both Nexus devices with this packet type, right? And that's just unacceptable for the Cisco Live network.
Was there like a gathering at that point where you're just like, okay, guys, what do we do? And then someone suggests we should just disable IPv6. The other guy's like, we should downgrade the Nexus. The third guy's like, no, let's do this completely different thing.
Yeah, no, that's exactly what. So we get together and we're like, well, we didn't have this problem last year or any of the years that we used this Nexus. So that was the first thing is like, do we downgrade a day before? Right? But then the question was like, well, we don't. To your point, we did upgrade. There was a very minor version upgrade on the Nexus that was taking place
Mhm.
from the previous year, right? But we didn't know if maybe that packet type we just got lucky last year and the packet type was just never on the network, or it was triggered with the upgrade. Like there's just so many unknowns, right? So if we downgrade, we can't say with 100% certainty that that packet type would still cause the behavior that it was, causing on the Nexus.
What happens a lot, right, is you have like a specific client type causing this, like, oh, it's like the new MacBooks with VMware Fusion on it, and then when the guy starts up his VM, boom, it sends this packet. So, like, it's not
Right.
your fault, it's the client, it's interrupt.
Exactly. But the way we were handling that, obviously not very graceful.
Of course.
And we're just extremely vulnerable, right? So yeah, we had the powwow. We start thinking of an action plan, and it's like, well, do we block it? We can't block it from the network level in the Nexus. It just doesn't have the capabilities to look inside of the v6 header and make any sort of decision on it, right?
And even if it would have that capability, it would probably just use the same function and therefore cause the same
Exactly.
crash, right?
Exactly.
That would be
Right.
snooping the packet and crashing.
Yeah, we're basically workaroundless on the Nexus, and not a good feeling. But luckily, what we're able to do is once we've identified the packet as part of the knock, they use a Cisco DHCP server. It's kind of an older one. I think CNR, Network Register, PNR they call it. If you're familiar with that, they actually fly a guy out from the BU who's there specifically to support that product. So it's like, well, maybe we can block it at the server. And we go over there, we take the packet, we're like, hey, we found this packet. It's getting to the server, and the server is sending a reply. We would like you not to reply. It's like, is it possible that you do not reply to a packet if it has this list of options? And then it was, thankfully. But not by default, right? Like he had to go in and write a script on the DHCP server to give it the logic to not reply to packets with this specific option stack. He couldn't do it right then, but he worked on the script, was able to implement it, and then we had to do some after hours testing, right? So it's like, well, we have the script on the server, we need to kind of stress test it a little bit. Let's send the packets again that we know will trigger it, and see if we still expose the crash. So that was what we did. After hours, packet gets replayed. Fortunately, no more crashes. The packet was blocked from getting back to the Nexus in order for us to snoop it and expose the crash. And we let that sit, overnight the next day, because that was Saturday night that we had the problem. Sunday night or Sunday, technically the show is live because there's labs that day. And then Monday is when the attendees come in, the World of Solutions opens, everybody's on the floor. And we were able to let that kind of cook all day Sunday. We didn't see a crash. That solidified the fix for us. We felt good about it. No need to downgrade. We had our root cause, and then of course I went from there and you know open the defect, and engineering gets involved. But that's the uninteresting stuff. The interesting part is we're able to find the needle in a haystack. We're able to get a workaround, and in my opinion, kind of like saved the show. Really, like there couldn't have really been a much worse scenario for the wireless side of the network. That year.
And you also identify a denial of service attack.
Absolutely. Yeah, no, like it turned into a PCERT.
PCERT is the team that is the product security incident response team, right? So they look into
Correct.
vulnerabilities in our products where someone could do a denial of service or any type of such exploit. And here it is a denial. If someone knew what packet was causing this, just replaying it on the Wi-Fi would have caused the problem, right?
Absolutely.
Luckily, no one knew what packet that was.
Thank God. Yeah, I mean, nobody knew. And then they get rated, the PCERTs get rated out of 10, and I think this one came in at like an 8.6.
Yeah, so from the moment you don't even need a direct access like SSH or Telnet to the device and manage to crash it, yeah, for sure, it's going to be a high severity bug.
Necessarily, you don't even have to be on the wireless. You just need to get that packet to the Nexus. So you could be multiple layer 3 hops away and just craft a packet destined to the Nexus, any IP address on the Nexus. It can just have one IP on the Nexus. If you send this packet to that device and it gets there, it's going to crash.
Because it doesn't have to be valid or authorized. Just the fact of looking at it is what makes it crash. So.
Exactly. Just looking at the packet. And since the packet's destined to the Nexus, it would look at it.
It's like the cursed packet.
Did you guys figure out if it was a newly introduced defect or if you just got lucky last year?
Yes, it was newly introduced. So luckily, the overall scope of impact from like the customer perspective on the code train that would have the vulnerability was very small. We were just very lucky in that we were running it. So it was newly introduced, and then of course it was like rapidly fixed.
It also shows the importance of using our own Cisco products on our own events so that we can figure out these type of bugs instead of our customers.
for sure. And then I don't want to, it was a very team effort with me and Richard and Chris. Like we all kind of were very instrumental in each part of that. I was able to go into the source code and identify that it's a DHCP 6 packet with some weird options, right? And then, Richard was able to get the PCAP. We were able to find the weird packet. Chris was able to replay the packet and crash the entire wireless to confirm our suspicions that it was this packet. It was really good teamwork, I think, under pressure at the time. The day before the show goes live. So
Having a strong DHCP server and the guy who knows how to configure it, like, oh, can you do a script on the fly for
yeah,
this? Sure, no problem, can do. It's not like, you have a random Windows admin with a out-of-the-box DHCP server.
for sure. Yeah. Yeah. It helps to have the developers of the product there to help you when you need it.
Yeah, definitely. I have a question, though, about that day before meeting. Who takes the final call? Because there has to be some responsibility in deciding, do we downgrade, do we disable IPv6? So for sure you have your voice, right, in the technical argument, but who takes the decision?
Typically, we share the decision. So, like the NOC has like NOC leads for the switching portfolio, or the KG, or Chris Gabrielson. He is the NOC lead there. Since we found the packet so quickly, we were able to that kind of helped make the final decision, right? Like we found the packet, we did the test, we had a full 24 hours of like cook time with the workaround on the server, to the point where we felt the need, like, hey, we have this one issue that we have a workaround for. Take that issue out of it, everything else has been fine, and we didn't want to risk a downgrade to potentially expose something else the day before the show, right?
Absolutely.
We share that with the NOC engineering lead, and typically they side with the experts on the technology, and they were in agreement too.
Of course.
But there's also some escalation managers from within Cisco CX that are in the NOC, that they're like the highest level of escalation people, and they also are in tune to those discussions, and they were in agreement with the technical analysis. So luckily there was no dissenting opinions on wanting to downgrade.
That's the good side of having a well-connected team, right? Like experts who respect each
Right.
other. If you have cowboys or guys who think they're smarter than the others, it doesn't work that well.
Yeah.
So how did it go this year now?
Oh yeah. So this year we actually didn't have the Nexus on the Wi-Fi distribution. That was like the big thing from the enterprise side here, is that we started to get questions last year. It's like, hey, this Nexus 7K is really old. Why is Cisco running a Nexus 7K as in the Cisco Live network? It was a question that was always getting asked, it seemed. And the big thing this year was, swapping that out with another platform. And we went with the Catalyst 9500X. So Silicon One ASIC, our own silicone, that worked out very well for us, actually. Leading up to it, the NOC team, they actually mailed me they sent the 9500X switches that we were going to use, because like, hey, like based on the data sheet, this switch will handle everything that we need it to do, but we didn't want to do it for the first time in production, right? So I worked with the team there. They actually sent me the switches to RTP, and I put them in the lab. I set up our Ixia, our traffic generator, and I was like, I want to push this thing further than we know we're going to push it at Cisco Live. So I loaded it up with all of the ARP entries, loaded it up with all the IPv6 neighbor entries, and let it sit there. I wanted to make sure that it was good to go.
Have you guys tried to send that malicious packet again?
No, we didn't send that malicious packet. Since it was specifically for NexusOS, and we were running iOS XE this year, we were safe from that. But the main thing for us was being comfortable with the scale, because that was the reason that the Nexus 7K was in there before, was being able to have that beefy control plane and a place to program all those ARP and IPv6 neighbor entries. And it worked well in my lab testing. So we felt confident in running it this year.
I have a weird question, and you can see it comes from a wireless guy. What is the incentive, or what is the point of changing the wired network device? Because I feel that I'm in the NOC for Cisco Live EMEA, and every time the data center is just way too powerful for the usage we have. And the guys, oh yeah, we want to test, the 40 gig Ethernet. We want to test 100 gig, which is, we don't have that internet connection, so we don't need that. Is it like
Absolutely, yeah.
you guys are trying to test the latest product just to demo it? What is the reason behind, why the choice of the 9500X?
Good question, right? And I think, It's always a fine line. If you've been in the knock, so it's always a fine line to try to balance, like, you want to demo like the latest and greatest, to kind of check those marketing boxes, but you also want to ensure a stable network for the entirety of the show, right? And the reason for the swap this year was, Nexus 7K is like a legacy platform. I don't think it's quite end of support. Some of the modules may be end of support, end of life, but we didn't really want to be running any a soon to be like end of life platform as the core of the Cisco Live network. I just think the optics for that, don't really look that great. And the 9500X was chosen, it's our latest and greatest. It's running our own silicon. It checks all the boxes for, being able to handle what the Nexus could handle, and that was the refresh this year, because every year it's something new, right? Like last year we refreshed the entire access layer, so they got like 400 new access layer switches. That was the big thing last year. Hey, we're running the new 9200 CX. It's our fanless switch. It's done great. But we still have this old Nexus in the core. So this year they had the budget to replace that switch with something a little bit more newer. We chose the 9500X. Another reason for that is like the switching guys in the NOC come from a Catalyst background. So it's good to have a platform that we're familiar with picking apart if need be, right? So we want to be able to troubleshoot quickly, and 9500X was a logical option for us.
Yeah, so there's a budget reason, but also you're trying to not change everything each year, right? You change one thing at a time.
Exactly. Exactly. We want to make a bunch of changes. Let's make one small change. We can talk about it at the show. Next year, we'll do something different. And to your point, though, from the wireless side, the wireless doesn't know the difference, right? And yes, we do have, it's almost like comically high bandwidth. Like we had 100 gig links. And the wireless controllers, I think they're only like 10 gig, Or maybe we might have had one of the 9880s. I think maybe those had 40 gig. Or they may have just been 10 gig. Either way, the bandwidth is like way more than we need. And in previous years, we had 400 gig Ethernet link. Like it's just, there's very few people at the show that can relate to that amount of bandwidth. It's not normal.
It's something that shocks me. People say, people always add up bandwidth, and you should not, because aggregate throughput is always much lower. People say, oh, my access points have a 1 gig port and now even M gig ports. And I have, 1,000
Right.
AP, so I need like 1 terabyte or whatever. No. And like you said, the 1980 can do 80 gigs at the controller, but we just never reach that limit, because not every access point is at the maximum. You always have management overhead. You always have people moving around, not using their phone. So in reality, you need to check what throughput you really need, because it's never what you think it is.
Right. And our throughput on the core, so all the wired and wireless goes through the core and up to the WAN edge routers. And the WAN edge routers, they topped out this year, I think, at like 6 gig throughput and some change. And that was only on one of the days. So I think, from a throughput perspective, we're not even using barely more than half of what we have available to us.
Exactly. So why do you feeling it's always overpowered, right? Like we always put too much.
Exactly. It's always like way overpowered to the point where it's like it's kind of funny how overpowered it is. Sometimes people would ask, why do you have so much bandwidth if you're only using, just a small amount of it? Like, well, because it's there. And we can, because it's cool, right? Like,
Yeah, and like you said, it's a showcase, right?
exactly. We got 100 gig links to the core. The platform can do 400 gigs, so that's another reason we did the 9500X. It's future proof for many years.
Yeah, by the time you need 400 gig, I don't know. It must be such a big event.
Yeah, we're probably going to be running some quantum network at that point before we need that
Possibly.
much throughput.
Was there anything else that was new? I know the wireless guys put Wi-Fi 7, of course, as well. So you had the new switches.
Yeah, had some Wi-Fi 7 in a specific area. It was actually funny because the Wi-Fi 7 APs need extra power over Ethernet. And the access switches that we have spec'd out for the show didn't support that level of PoE. So like at the last, like the month leading up to the show, we had to push through a specific model of switch to be able to get the PoE requirements that the Wi-Fi 7 APs needed. That was another crunch time thing that happened this year. Which is funny because the access layer switches we use, there's an 8 port and a 12 port. We get the 12 port. The 12 port doesn't have the PoE requirements that the APs need, but the 8 port does. So it's just unlucky, and they had to like rush some of those 8 port switches to get them in to be able to do Wi-Fi 7. But they demoed some speed tests, and it was screaming on the Wi-Fi 7 stuff. So they had some really good results with that.
Yeah, there's that, and there's power budget as well, because maybe sometimes you budgeted like, oh, this switch will have enough for, I don't know, 6 APs. But then if they use 60 watts instead of 30, like, oops, now we can only power, I don't know, 3 APs or 4. So where you plug the stuff, like, it changes a lot of things. I always try to tell people that, as a customer, you can migrate progressively. You can say, I can already get the Wi-Fi 7 APs. They run quite fine on 30 watts. And, you can iron out and upgrade your switches later on in your next refresh and so on. But here for the event, we kind of have to show the product at the maximum capability, right? Otherwise people are going to ask, like, what are you doing? Why can't I do this? Why can't I do that? We didn't have enough, power budget. Like, come on, you're Cisco. So that's why it's trickier
Yeah.
for us.
One interesting thing with the wireless this year is, have either of you ever been to Cisco Live or San Diego, that venue?
Nope, never in the US.
Gotcha. Okay, so it's a big convention center and it's right on the bay, like it's right on the water. So, and there's a military base right across from it. And the third floor of the venue is called the sales pavilion, and like the roof is like this, very, it looks like a ship sail, right? Like it's not actually a ship sail, but it's like this fabric material, and then the walls are glass. You can kind of see out, you can see the harbor and whatnot. And they were having some very, very spotty Wi-Fi up there, like throughout. And don't know much about wireless, so I'll try to speak to what I was able to understand. But eventually, they were able to figure out that there was a military ship across the harbor that was like equipped with all this like radar, these radars that were, circling around, and all of the radar was penetrating the third floor of the venue, and it was just causing a lot of channel disruption, right? So they had really bad wireless up there, and they were constantly like trying to maximize or optimize the channels. Something about dynamic frequency selection came up. They had to turn off some of those channels, but at the end of the week, they do a knock panel presentation, and like they actually had a picture of the warship on the slide saying like this radar was, coming through and disrupting our wireless.
It's not us.
So just unlucky timing. Yeah. Yeah. So I thought that was interesting.
Yeah,
Um,
civilian radars are quite predictable. Like they always use 1, 2 specific channels. Military radars, like they don't respect your rules. They
right.
just will use the bandwidth.
Exactly.
You could just go away.
Yeah. And we're right across from a major military installation, and it
Yeah,
was coming
exactly.
right through the venue.
And if it's not one chip, it's going to be another one, and there's always going to be something. So yeah, that's tough.
Absolutely. And then it just being glass, like there's nothing to kind of downstairs, it's, this big metal container, but concrete, and then upstairs it's all glass, so everything was just coming right through, causing all sorts of interference.
I have to ask one thing now because this year the event was placed under the AI umbrella, right? Uh, do you have AI tools, or like, do you have any specific fancy tools in the NOC you were using?
So yeah, we have one non-serious and then one tool. We did have a use case for AI. On one of the switches, we saw that there was a specific queue that appeared to have some packets stuck in it. It was a low amount of packets, but something we wanted to keep an eye on. And we are actually like, well, let's see if we can use AI to write an EEM script that will monitor this queue for us and alert on it if it goes over a certain threshold. And it did. Like it wrote the EEM script and we deployed it on the wireless distribution switch. That was our use case for AI. Hey, we saw this issue, write a script. Did it in no time. We have it on the box after doing some testing. It worked fine. And then we also used AI to create Garbage Pail Kids cards for all of the enterprise networking people in the NOC. I don't know if you're familiar with Garbage Pail Kids. They're like little baseball cards with little like funny illustrations on them, but we were using those kind of as a joke. But AI was all over the place. I mean, it was AI live this year, and I'm sure you guys saw the keynotes and whatnot, hearing Chuck talk about it. But it was there was heavy AI, kind of like heavy single pane of glass in previous years, and heavy Meraki.
It's actually quite exciting because I was expecting a lot of buzzwords and just marketing fluff, and I'm like, oh, that's actually interesting stuff coming up. So
Yeah, the AI canvas looked pretty interesting, so looking forward to seeing more about that.
And now this is the second part of the show where we ask our guest a question that's not directly related to the story, but that's interesting anyway. So Brandon, you mentioned in the introduction that you were working with automation, building some automation to make your life easier. Can you just tell us a little bit about that?
Yeah, so the big one now is developing this tool called Highlight, with one of our attack escalation engineers. It's a tool to kind of quickly pull out data points of interest from a show tech. Because I feel like a lot of our attack engineers are always getting show techs, but some people either just don't know how much information is gleanable from that, and others may. But I wanted to be able to pull any and every interesting data point out of a show tech and give it to someone in a easy to understand format. So it's a web app that I'm working on. I use Angular for my web apps. I don't know React like most everybody does, but it's coming along well.
What do you exactly mean by data point?
Yeah, so we've broken it into different modules, and we're calling the app is called Highlight. So I'm calling the data points highlights. So and we have like interface modules. We have reliability, so like health of the platform, modules, line cards, things like that. We're working on our layer 2 switching module. We have a logging module for logs that stand out. But one of the things I think is interesting, so a simple example would be like Ethernet flow control triggering on an interface. That's something that a lot of people typically look over, right? But it's indicative of congestion on the other end of the link. And in certain scenarios, like that may be extremely relevant to the problem. And it's just one little counter on an interface. So as part of the automation, it's able to detect that. It gives like a little highlight alert in the front end, and you're able to see like, okay, so I've got flow control kicking off on this interface. Based on whether the problem has anything to do with that, it might be relevant, it might not. But the point of it is like that information is there if the user needs it. And I was able to actually zone in on a escalation because of that one little highlight early on when we started testing the app. It was if you're familiar with like app gigabit Ethernet interfaces on switches, it's where we can host our kind of like container infrastructure. So we can do app hosting on our switches now. So we've got all sorts of like Thousand Eyes, you can run it on the switch. It runs in this like container infrastructure. And we have like Cisco Cybervision, which it's another container that we can run. It monitors like industrial networks and things like that. We were able to kind of pinpoint a very interesting issue with our app hosting infrastructure and like internal channel congestion in the software. The only symptom that we were able to see was pause frames on that virtual interface. And I was like, how do we have flow control kicking in on this app gigabit virtual interface? I wouldn't have looked at that unless a tool pointed it out to me. So it's not something I typically look at, but it's a good example of like attention to detail and then like getting that attention to detail like fully automated. So
Is this something that applies to any type of show tech or just Catalyst specific?
it's any Catalyst 9000 switch. It will run with limited functionality on any Catalyst switch, but it's being developed specifically for Catalyst 9K.
That's cool. What amazes me with the show tech is that initially they were built as a quick way of having an overview of the device, the health of the device, all the features and all the configuration. And with time, they got so big, man.
I know.
Some of them are even over a gig. It's just impossible to process that by hand, and we absolutely need automation to help us there.
Yeah, Nexus has this massive show techs. And like if customer had an outage, took a bunch of show techs and reloaded things, from a root cause perspective, it's great to have that level of information. Like you have every process is logging everything in a Nexus show tech. It's easy to look back, or not easy, but you're able to look back and kind of see everything that was going on. Like Nexus will even log it down to the BPDU, so you can see it, spanning tree BPDU when an issue may have triggered. Catalyst just does not. We don't have that level of show techs. Like we have different specialty show techs you can run, but for the most part, they're not quite as large as Nexus. But yeah, they can get quite large. I don't know about the wireless controllers. If you guys are in wireless, I know they probably have a lot of information also.
The more access points you have, the bigger the show tech is. Since you can have up to 6,000 access points, you have the statistics of each of them, and it can be massive. It can run like you run the command, and you can go for a coffee and a second one, and
Yep.
more.
Hopefully they don't run it on the console, because then it's going to take all day.
Exactly. I always try to advise people to run it from the web UI, so it zips it and it's offline. It's not on the terminal. Some people, they still like log the terminal, the SSH session, and like print it.
Yep, term on,
No.
show tech.
First of all, you can redirect it. You can redirect the output to a file. It's even better. But don't just print it, please.
And I think that wraps it up for this episode. Thank you, Brandon.
Thanks a lot. It was super informative for Cisco Live US.
Yes, indeed. I learned a lot. Thank you.
It was great to have you.
Yeah, thanks for having me.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on the Cisco Podcast Network in SoundCloud or your favorite podcasting app. You can also find us on our own channel called Cisco Tech Stories in every podcasting application. We are also on X at Cisco Tech Story without the S, and on Instagram and YouTube at Cisco Tech Stories. Thanks, and see you next month.
Wrangler sat with his head in his hands. NexusOS playing tricks, breaking his plans. DHCP Viva sits like a ghost in the wires. Time ticking fast, stakes climbing higher. Cisco Live's tomorrow, the pressure's insane. Packets are laughing, they dance in his brain. Clocks feel like riddles, aside for tease. Brandon won't sleep till he bends it to please. Oh, Brandon, your battle's in code. Ride that bluegrass wave, lighten the load. Through the haze of bugs, your mind's a spark. Fixing the network before the show starts. Guitar strings hum, a psychedelic flow. Dreams of a workaround start to grow. He stares at the screen, a gleam in his eye. The fix is a whisper, the code starts to fly. Next to midnight, a breakthrough appears. He types with a fervor, erasing his fears. The ghost is tamed, the system aligned. Brandon's solution, one of a kind. Oh, Brandon, your battle's in code. Ride that bluegrass wave, lighten the load. Through the haze of bugs, your mind's a spark. Fixing the network before the show starts. Your battle's in code, ride that bluegrass wave, lighten the load. Through the haze of bugs, your mind's a spark. Fixing the network before the show starts. Guitar strings hum, a psychedelic flow. Dreams of a workaround start to grow. He stares at the screen, a gleam in his eye. The fix is a whisper, the code starts to fly. Minutes to midnight, a breakthrough appears. He types with a fervor, erasing his fears. The ghost is tamed, the system aligned. Brandon's solution, one of a kind. And it's to midnight, a breakthrough appears. He types with a fervor, erasing his fears. The ghost is tamed, the system aligned. Brandon's solution, one of a kind, one of a kind.